data warehousing concepts. Okay, we'll start with the Hive. Okay. So before discussing about the Hive, I will try to uh, give some clear picture about the Hadoop. Okay. So why and where we will use this Hive and how this Hadoop will help us. I will tell you. So, as you know, like we'll be using this databases for managing data. So that's in case where we have less amount of data. Let's say maybe uh, it's data in the GBs or TBs. Whereas in this Hadoop will help us to uh, uh, this will help us on the kind of a big data where the data is in the maybe petabytes or zettabytes. Uh, so so it can easily handle the storage of this data and it can process the large data sets. Okay. So for this, like actually what they did, they have created this Hadoop ecosystem. So if I show you, yeah. So I'll try to give some understanding about this ecosystem. So you will get to know where our Hive stands and what it will, where it will help us. So so exactly like if you see this is kind of ecosystem. You know about the ecosystem. Ecosystem is nothing but something. It's if you see our nature ecosystem, we are everything is dependent on something. So if you see from the plants, we take the oxygen and we give the carbon dioxide. So that carbon dioxide again, it's helpful for the plants and and the food uh, and the food cycle. So just like that, in this Hadoop ecosystem, for each and every component, it has their own work to handle. Okay, so if you see here, I will start with this. We have around 4 layers, or actually, it is showing in the 4 layers. So everything is dependent. For example, so you can see this is the date for the data management, and this is for the data access. This is for the data processing, and this is for the data storage. So we will discuss each and every component individually. So you will understand why we will use the Hadoop. Uh, we'll start with this HDFS. HDFS is nothing but the first there is one component which is a HDFS. HDFS stands for Hadoop distributed file system. How this works and why it is this is one of the main component in Hadoop ecosystem, where this is kind of a foundation in ecosystem. So mainly, it is responsible for the storing the large data set across all the clusters. Uh, so how this will be useful means, uh, uh, for example, try to say show it here. Okay, so let's take Hadoop, HDFS. HDFS is nothing but whatever you want to store the data. So what exactly it will do means, instead of storing this data in one place, it will try to store this data in the multiple locations. For example, uh, in the you want to store some information in the HDFS around 10 TB. How the database will store normally the traditional database? For example, if take this is the database. For example, you want to store the 10 GB. This 10 GB will be stored in the same place, means in the same server, same place. If you take the HDFS, if you want to store the 10 GB, it will split the files into multiple files and it will save. So, uh, whenever you store some information, it won't store information in the only one place. Means, for example, for this working with the Hadoop or with the Hadoop file system, uh, it has multiple servers, means multiple databases, which can act as a storage capacity for this HDFS, where it will store into different locations. For example, you are giving some data. It won't save the data in one place. So it will store some information here, some information here. But whenever you are trying to recollect the information, it will get the data from these servers. It will combine here. And if you are requesting that data, it will present it to you. So that's how this HDFS works. Uh, let's take an example like actually uh, why this exactly it will follow means uh, it's a kind of a fault tolerance means, for example, if one node fails, actually I'll tell you one thing, the advantage with this uh, SDFS, I'll tell you. Yeah, let's take this is a node 1. It will save the data in the nodes. So what it will do? So if you are giving some data here 10 GB, it will save initially in the node 1 2 GB, 2 GB like this. After that, it will start taking the backup of this one also in node 2. Means this data again you will have here also. Okay. Sorry. So whenever you're trying to store some information, right? So it will store initially here, and then it will take the backup in this location. So even though if something happens, if this node fails, if you lost one of the data here, this Hadoop will try to connect to this one, and this will take the backup. Okay. So that's how this Hadoop distribution file system works. Even like let's say take uh, for example, it depends on us how many nodes you want to add yourself and you want to store the data. You can add multiple nodes. You can add 3 nodes, 4 nodes. You can take the backup of this data whenever something happens. And no, for example, you are requesting some data from node 1. If this failing, it will try to connect to node 2. Even this node also failing, it will try and connect with node 3. So that's how it works. So in this node also, again, this file copy will be saved, kind of backup. So whenever something happens, if I can't able to access some data here, I can't able to access some data here. So it will try to access between all the 3 nodes, which is data needed by this HDFS, and finally it will combine all the data and it will give it to us. Okay. So just think like in your computer, instead of you saving one data in one place, you are saving this data in the multiple folders. What is that? If actually if you're saving some data in database, all the data will be available in this here only. But in the HDFS, it will create multiple folders. Whatever you are saving data, it will save in multiple folders in multiple locations. So that's how it will save, and this will be useful for the uh, data retrieval purpose. And next, the components comes is HBase. HBase here, yeah. So HBase is nothing but
Hi, Mani.
uh,
Mani, I have a doubt. Means if I want to update, so do I need to update the each and every node, or I have any master node so that I can update there, and meanwhile it will update in the slave nodes.
yeah, good question. So whenever you are updating, so actually uh, this will actually follow the one concept called the master nodes and the slave nodes. There is concept in here called the master node and slave nodes, or we can say parent node and child node. We can say either anything. So whenever you are trying to update on the main node, so we will take it one node and we'll update in that particular node. It will try to replicate the same information in the other nodes as well. So we don't need to go back and update each and every node. So if we update one node, that's fine. Still, it has to be a master node, not the slave node. So if you try to update this slave node, it won't update this master node. But if you update here, something will update in all the nodes. So next one is a HBase. HBase is nothing but it's a kind of a so we will just in the Hadoop distributed file system, uh, we will save only data or some of the files here, whereas in the HBase, it's in the uh, on top of the this HDFS. So it is not showing here, but on top of HDFS, we'll save this HBase. So where this HBase acts as a uh, NoSQL database. So on top of the HBase, HDFS will store the this HBase where we will try to collect real-time access to the large data sets. So, uh, so you can't directly access this HDFS. That's why we will use this HBase to connect to this HDFS, and we can quickly check the changes on the data level, whatever exactly we want to do. So this acts as a kind of a layer where we can work. We can't directly work with the HDFS. It's a kind of a back-end process. It will happen in the uh, servers. So this is kind of a functionality. It will happen. We can't handle it directly. So that's why we are using some this Hadoop ecosystem. So this is a layer where the data storage will happen. Means the information we will store. Next we have the map reduce. Map reduce means uh, it's kind of a cluster management. Cluster means uh, I'll tell you. So actually, uh, for example, I told you right. This Hadoop will work on the different clusters. What is a cluster exactly? Cluster is nothing but the some group of tasks happens in the one particular location. The group is called will as a cluster. So like that, we have multiple clusters. So where we want to handle the entire process. For example, let's take this is a map reduce, or let's say some uh, group of task happens. At the same time, again group of task happens. Okay. This entire thing, whatever you are doing, so some group of tasks happens. So this entire thing will consider as a one cluster. So like that, we have multiple clusters in the Hadoop. Same like this. So these clusters will be handled by this map reduce. So map what will do exactly? There are two, if you see, map is one thing and reduce is one thing. What the map exactly do? It will process the data on individual nodes. What reduce will do? It will try to aggregate the results across the cluster. So what exactly this map reduce means to means, so it's a one of the component where, so the continuously parallelly the whatever the execution happens in the Hadoop, it will split entire data into chunks and it will try to make that HDFS works. I'll show you. Uh, if I show you a picture, that would be map reduce. I think there will be one picture. Yeah, this you can understand. So this map reduce exactly whatever like the data we are getting right from the to the big data. It will do in fun take one functionality. It will share each other between the map and the reduce, and it will try to uh, divide the whatever the multiple data, split it. So entire this Hadoop ecosystem works in the chunks of data only. So whatever the data you will give, so it will try to share among the components and works. And finally, this map reduce will uh, like if you see here, there are two phases. This is a map. Mainly, it will utilize this. Uh, what exactly say? Just a second. So you can say this is nothing but a CPU here. What exactly the CPU will do? It's a kind of a processing unit, right? So that's how this map reduce works. So whatever the data you are giving, the kind of processing it's need to be done, that will be handled by this map reduce. So I told you, right? So here, here in this, for each node, I need to split the data. But sometimes, because of the storage issue, for example, you are giving 9 GB, not the 10 GB. How the system will get to know for each node how the data should be splitted and data should be given. So that part will be handled by this map reduce. So it will interact with this HDFS and it will provide the details. What is other thing we have? Yeah. Uh, so this level will store the data. Uh, this we can't access. This will only in the backend happens. This we can access it at particular layer. This is also map reduce. Even this is kind of a processing unit. Yarn is something, but so YAN full form is yet another resource negotiator. For example, I say uh, here, right? So I told you there are multiple nodes I can work on. Like this, we have multiple nodes. Not only these nodes, there are many hundreds or thousands of nodes we'll be working on. So this yarn will, what exactly it will do, it will kind of that resource traffic controller. It controls the traffic between the clusters. So whatever the data is coming or data is going or the process happening, right? So that will be uh, you told you right like Irfan, you asked her like where exactly we need to do this one. So this master node and slave node uh, task will happen here. It will there will be one master node and there will be one slave node where this master node uh, is responsible for the slave nodes. Whatever, if you give this information or some of the processing information to the master node, it will make that slave node will work uh, here. Uh, yeah, architecture. So the thing is like uh, a Hadoop ecosystem. Each and I'm showing you as this entire Hadoop ecosystem as a one part. In this Hadoop ecosystem also, if I show this HDFS, each and every component will have its own architecture. That is the one thing. If I show you how the Hadoop architecture works, you can see it here. So internally, uh, it will handle, uh, wait a minute. Yeah, not this one. Yeah, this one. So I told you, right? One master node. So this is slave node. So uh, each and the slave node also have this data node, node manager, map reduce. So these components, uh, just like one of the CPU for you. So whenever you are trying to do something, it will try to create one CPU. What will CPU will have? Consider I'm taking one node. What is this node? It is one CPU. What will your CPU will have? Your CPU will have RAM, ROM, everything, right? Just like also the CPU will have some memory, maybe uh, 10 GB RAM, 100 GB ROM, some storage capacity, maybe uh, uh, one 1 TB. So not 1 TB, maybe 10 TB. So some configuration will be available for each and every node. Okay. So just like this, for this yarn also we have one architecture. If you see, uh, we will have not only one client. For example, Manideep, me as a one client, you guys, each individual person as a one client. So we are giving one task to the HDFS. We are giving it. So we don't know like what exactly task we need to be processed and which not and where exactly we. So entire this will be handled by this yarn only. So yarn what will do? It will create one resource, just like if in a company, how we have the employees for each and every work. This will create one resource for it. Uh, it will give some task to put that particular resource. Okay, I will. This master node will create one slave node where it will give. Okay, there is one request came from the client. Take it and work on it and do the map reduce task. And same like it will give the uh, uh, this task to multiple slave nodes. So, however, we have this manager in our company to handle the team members. This acts as a manager where it will manage entire task and all. Okay, how it will do? It will, uh, for example, you are giving one uh, work. For that, it will assign the resource, and what it will give, it will it will give us to one cluster, one group of tasks, and what it will give, it will give the map reduce task, map reduce, and what it will give, and even it will give Hive jobs. This entire information will be given to resource one. Let's take resource one. So we got one more request. For that, this resource is already busy with one task. What it will do, the same will be given to resource two. Okay, resource one is busy. Resource two, you take some information. Again, maybe we got some large data of large information which has to be processed. So this is not sufficient. It will improve it. It will give 20 GB RAM, maybe 200 GB ROM, maybe 20 TB memory. So that's how this works. So whatever the resources we have, it will try to utilize them efficiently, or else it will create them. Actually, like yeah, yeah, that's all. So that's how this yarn works. So this is just like a manager, and these are some of the employees. We have the resources. Even whenever we are getting some requirement, it will again just give it to here. And this part, uh, this part is a data processing, and this part comes under the data access. What are the data access we can do? I will tell you. Okay. How we come later. Let's see the pig. This person not given spark. Okay, not an issue. Okay. We'll discuss about the pig. What is pig? Pig is nothing but it's a high level language for processing this data unit. For example, uh, Pig is responsible for example, from the external sources, you are getting some information into the HDFS. This pig is responsible for converting that external code into the Hadoop ecosystem. Pig will convert external uh, code into the Hadoop environment. So Hadoop will not may not understand the another code or another information. What exactly this pig will do, it acts as one of the layer in Hadoop. So it will try to uh, analyzes the code and it will convert that code into the Hadoop environment. Okay. Even Pig has the architecture, Pig architecture. So this is how you heard about this compiler, right? This is Apache Pig. This is like Pig. This is actually Pig Latin scripts. Actually, uh, uh, it uses one of the language called the pig Latin scripts. You don't need to worry about it because we don't work on the pig. So actually, whenever the data is coming, it will have some own server where it will uh, get the data. It will parse it. Means, however, the data has to be collected. It will collect it and it will compile and it will execute it. You know about the compiler, right? So compiler uh, which what exactly, how can I say? So whatever the language you are getting here from the external code, it will try to convert it into machine code before the program runs. For example, I want to store some information. I don't know how this Hadoop will read. So generally machines won't understand ABCDs or any characters, nothing. They will only understand ones and zeros. So Hadoop ecosystem has its own uh, uh, what we say, the code, the program. According to that program, this will convert into that one. For that, this map reduce will help them. So this is a peg one, and we have Mahout. Okay, mostly we don't use this Mahout anyway. Uh, Again, we will use pig and Spark. So Mahout is nothing but it's majorly if you are working in any kind of machine learning algorithms, this will be useful. Like, so if you are learning any kind of using very massive data, on top of it, you want to do some machine learning algorithms. You know about machine learning, right? So machine learning is nothing but you are feeding some information to one program or one algorithm, and you make understand that machine what exactly it is. For example, you are passing one object to a this one. It will try to analyze the information whatever it has. It will try to match that information and it will reply back. So that's how this machine learning works. So this math will be help you for creating machine algorithm on top of massive data sets. The large data sets you are working on, this will be helpful. Generally, this will be useful. Let's take uh, you're running one e-commerce website where you have some streaming data is coming in. What is about the streaming data? You will data keep on generating. In that case, on that, for example, let's take this Amazon. In the Amazon, if you open any uh, one of the product and you close the Amazon website, it's keep on suggesting in the another websites or in the Amazon wherever you see that related to that particular project, you will get the notifications. So how this works in the back end, they did some of the algorithm to the customer, or this one will be useful for the fraud detection or social media analysis. Many What is exactly Avro? Avro, it's kind of a data set actually. It will store the data in one format. I'll show you what format it is. Uh, it's kind of a serialization system where uh, you will store the data in the just like a JSON format. So it can read the data because whenever your data coming up into the uh, from from the outside location or from the external source to internal one, it kind of a clumsy. So you want to bring it up into a one defined data structure, and you want to maintain some uh, you want to maintain some data consistency. In that case, uh, this Avro will be useful. So why? Uh, it will reduce the redundancy, and it will create some data defined structure, and it maintains the data consistency. So this Avro, what exactly? I will show you the Avro format. Uh, uh, Actually, uh, the whatever the data we are storing, right? We can't read it directly. So it will store the data in the dot Avro, but we can't read it directly. That's why what exactly you will do, we'll convert that Avros into the JSON format, which is readable by the human. Okay, I'll show you. Vector dot Avro. So there is some information I got it where there is arrow. Actually, in the systems, it will store the information like this. If I try to open in anywhere, it's kind of a encrypted information, okay, which you can't read directly. I agree. Like some of the information you may read, so not entirely you can read. Some of the you can see some special characters or some uh, unwanted information. That's why what exactly they will do, they will convert that arrow into a JSON format where you can read the proper information. This is the actual data. If you open this one, whatever you are reading, this is not the actual data. So this is kind of a data structure. In the behind, it will store where it will maintain this arrow. Arrow actually how it will store. I'll show. For example, you are giving your name, your age, salary, your location. So whatever the data, it's in the table actually. In the table, I'm storing this information, name, everything. It will try to keep in between these two. And in these double quotes, this is called the key pair value, where uh, uh, key value pair. This is a key actually. This is a value, and we have comma. So this is how it looks like. Even though you are storing some information, uh, some information in the table format somewhere, but this will helpful to store this information in the you can see, right? So the entire data we can send it in a single line only. Even though, for example, I have some information over here in the table in the multiple columns. So this is easy way which computer can transfer the data. So we have this information in the multiple columns. So it's in the tabular format. So it will convert this into arrow and it will store it. Okay. Even by using JSON formatter, you can convert this information. You can see, right? So this is understandable way. This is actual format. So easily understandable, key and value pair. So that's how this works. So, um, so for example, uh, you are living in the multiple addresses. For example, Uh, let's take maybe you are living in the address. Something. But again, you changed it. What exactly? Or you have some multiple address. Maybe consider this as a permanent address. You have some temporary address. For that also, it will create one internally, one more information. It will store the data. Address 2, address 1, 28th line. So, like how it will create again the JSON. Okay. We call them as a nested JSON. Yeah. It's the common. Yeah. So like this, it will store the information. For example, for the same, likewise, you have phone number. It will do the same. For the phone number, it will do the same. So likewise, like you have multiple phone numbers, multiple address, mail IDs, everything. It will try to create, add this square boxes in between. Add it. It will have multiple JSONs. It will send it to the system so that it can easily read this one. You can see it, right? So in a single line, you can send the information. Even though we have a lot of information, it's easy to send and receive it. We have normally we have other formats also. Just leave it. Okay. Uh, so what are the use cases we have with this Avro? So this is a main uh, format which is used by not only Hadoop for each and every application. Some of the they will use this JSON format to exchange the data. For the long-term storage data capacity, this will be useful. And whenever there is something, the information changes. In CSV, uh, you don't have any particular schema. If yesterday I shown you once CSV, right? So in this JSON format, it is having some schema where this will helpful for the storing the information. Okay. Uh, so Avro is one of the format. Even okay. Actually, market. We have one more kind of dot packet files we have. This will also used by the Hadoop environment. Okay. So okay, we'll come to the scoop. What is scoop exactly? Scoop is nothing but uh, it will try to import the data from the databases. So uh, whatever the data we are coming on, actually we have scoop as well as there is one more component called flume. I don't see flume here in the. I think this is the old one, but normally we'll even have the flume as well. What this flume will do? Uh, it will streams the real-time data from where? From social media or sensor data into the HDFS. So, scoop is nothing but, for example, I want to send some information. This scoop will be helpful to move the data from various sources to the HDFS. That's it. It won't do anything. We have this. This is actually a data access layer where they will access the data and they will work on it. And there is one more layer called the data management layer where we have this Uzi, Chukwa. Okay, Flume is here. Okay, fine. Okay, Flume. Okay, I'll tell you. Okay, well, Uzi. Uzi is nothing but a workflow scheduler. Uh, Yesterday we discussed, past 2 3 days we discussed about this uh, control M, right? Just like control M, how is one of the application. Uzi is like the same. Uzi is same as control M. What it will do, the control M, it will do the scheduling. So it will, it is a workflow scheduler which manage all the complex workflows, executions and all. Apart from that, uh, just like control M, it will try to create it will define the dependencies and it will execute those jobs between the dependencies and all. Okay, this is a kind of automated processing where uh, just like control M, it will create uh, Hadoop jobs internally, and just like I told you, right, there will be predecessor and successor and everything. It will create that execution order, for example, which job has to run before and after. After that, like according to that, this will execute it. Okay. what is Chukwa? So Chukwa also, uh, for example, uh, s- while I'm working, there might be some, if I did some job run, it might success, it might fail, or it might be in the hold, or it might be some other waiting or something for server. So whatever it is, this information will be stored in the logs, right? So this Chukwa is nothing but it's a kind of a collection of the logs and all from not only jobs, from each and every component. Whenever something will happen, there might be uh, one log will be generated. For example, I am let's take I am using this pig. uh, I might be getting some data, so that data flow will maybe for that I'm generating one log, and for this yarn also I'm generating for that I'm having one log. From each and every cluster or each and everything, what are the logs is generating, that will be saved over in this chukwa only. So it is kind of a collection of the centralized log data which is generated from multiple clusters, okay, or from the different servers. uh, just a second. uh, Roman zookeeper. Yeah. So we are discussing about this chukwa, right? So in the so this will be helpful for the centralized logging or the real-time monitoring. How we'll do the monitoring? Uh, by analyzing those logs and all. If I do the analyze the logs, whether I'll get to know whether it's success or failed or whatever it is. According to that, I can do the real-time monitoring, or I can do the troubleshooting. How we will do the troubleshooting? By identifying the errors and all. You will try to restart the system, or you restart the job, or what are the uh, issues happening, or uh, whether you want to have some any exceptions or any performance issues and all. So for that, you need to do this troubleshooting, right? So you want to do this troubleshooting, you need to get to know the status of each and every component, how it is working and what exactly they're happening. So we will access these logs and we'll do the troubleshooting. So how this will work, uh, the chukwa, uh, whenever actually chukwa have a agents. What agents will do? Agents are a small programs, okay, as lightweight small programs where it will deploy. uh, Actually we have this agents with this chukwa. Whenever like there is one log generated, that will be collected by these agents, okay. no, no, like image this also. So actually, how this is how it works means in for this Chukwa we'll have this agents. For each and every log we have this collector. This collector will what do? They will just give the log information to the agents. This agent will give those logs to the Chukwa. So that's how it works. So this is something where the monitoring will happen. So entire monitoring will happen in this level. In workflow monitor, this is actually just like a controller. Chukwa, it is one of the monitoring. Even Flume also it has a monitoring capacity. Zookeeper is nothing but uh, zookeeper. Zookeeper is nothing but one of the management uh, component where it will ensure, for example, uh, just like I told you, right? The manager and the employees example. No, this is kind of a supervising component where it will ensure, for example, I am giving one task to pig or giving one task to map reduce or giving one task to hbase. So it will ensure that each and every component is working together and all everything are in synchronized way. For example, I am giving one task to let's take uh, from Uzi, I'm triggering one job. What exactly is to do? It has to take some data. It has to give it to the pig. The pig will do the map reduce, and the map reduce will after map reduce, it has to save the data. So this entire task, whether all are in sync or not, this zookeeper will handle. What it will do exactly? It will check for the coordination, whether the coordination between all the components and all are in sync and working together. That's the one thing. And naming of each resources and all, it will check. And there is one more call. It will do the name. It will name the cluster, and it will do the leadership. That's the one thing. Like a kind of every component, whether working and or not, it will check it. What we missed it, Spark. So actually, we have one more component called the Spark. So Spark is nothing but actually from the starting onwards, this Hadoop ecosystem was not stable. Like it's keep on changing or they keep on giving updates for this Hadoop ecosystem. So for this map edges also, uh, the mode in the mode with the advanced version is a Spark for the map reduce replacement. So it has some maybe more processing capability and all, and it will do the parallel processing and all. This Spark alternative for the map reduce. So it can do batch processing, stream processing, everything. So out of these components, instead of maybe using pig or some of the components, they reduced it to Spark. So this Spark directly access the data and it will do the batch processing, machine learning also. And in this only, we can set the Hive in the Spark itself and we can work on it. So these are some of the components I can say. So if you are only learning Hive, it's fine, but you need to know how the internally Hive is working with other components. Okay, just a second. Okay, we'll start with the Hive. Uh, so what exactly Hive is? So Hive is nothing but a simply a data warehouse for the this Hadoop ecosystem. So I can say on top of the Hadoop, you can have this. You can create your own SQL. On top of it, you can run your SQL over there. So, for example, if you are familiar with SQL, this is called the HQL or HighQL. So both are same only. So uh, there is nothing but much difference. So if you learn this SQL, right? So it will be useful for you. So it is easy for you to understand this HQL. So I'll tell you the difference between uh, normal database and this HQL. So, for example, uh, okay, just a second. Okay. I traditional database. So, what exactly the high focus is about? So, mainly, it will try to analyze the large distributed data sets. Okay, what exactly the traditional database do? It will manage the structured data in what? OLTP. Okay. So majorly using this Hive, wherever the distributed data we have, we can we can analyze and we can do the uh, manage it the large data set. Whereas in a traditional data set, it's normally it will only manage the structured data. That's it. So compared to this Hive and traditional database, Hive has a good amount of scalability. For example, uh, maybe you're working in server one. They gave it. Uh, it has only capacity of 100 GB or 10 GB. You can scale it to the another server. Whereas in this traditional database, we can't do the same. The scalability of massive the large data set will be a difficult one. And oh yeah, even this can support one of the structured, you can semi-structured data also, it will handle. But this traditional database which can't handle the semi-structured data. Okay. So mainly we'll discuss about the features and DBMS. DBMS database both are same only. So what exactly we are discussing? So let's discuss about the purpose of the Hive. I'm saying analyze the large data sets. What this will do, manage the structured data in OLTP. Okay. So this is the one thing. And what is this? If I come to the storage, this is in the distributed. Means it's distributed in the different places. And this is in the centralized one. Means the in only one particular location will store the data. Okay. And scalability. How it can be done? It highly. It's as limited. Coming to the cost, it is a cost effective because uh, the entire thing will be the hardware or the servers and will be uh, we don't buy it. It will be managed by some third party. So for this one, it can be expensive because we need to buy the hardware server, or we need to buy the licensing to maintain that one. Coming to the performance, it is slower actually for large, small data sets because it can handle the large data sets, but it can't handle the small data sets. For the okay, What about the data schema? It's a flexible. Uh, Flexible, why I will tell you. Because actually, in this on read, because uh, whenever you want to store some information, initially it won't check for any structure in the table. It will store the data first, and then only it will check for the structure. According to that structure only, it will save the data. But in this is a actually rigid schema, means schema on write. So initially, I told you, right? It will check for the structure of the table. It will check for the structure of the table. If this structure is available, according to this structure only, it will save the data. If not, it won't save the data. Okay. So coming to this Hive, so the advantage is like uh, initially it will save the data. It will go back and check for the schema. If the schema is available, according to that schema, it will save it, or else it will respond us back to saying we have the different schema. According to that, do you want to save the data? It will ask. And data integrity, it is less strict. I told you, right? Why? After getting data only, we are reading the schema. So we may lose some integrity. Here, we have some data consistency and accuracy. Why accuracy? If you want to get some data, for example, if I see here, I want to have employees who only the graduated persons. So I may add here one column. I may add one condition. Uh, the employees who graduated, uh, I want to get them in on board. So I can add one condition. So whereas in Hadoop environment, initially it will take all the employees or all the candidates who already passed the 10th inter, or they are graduate or postgraduate. Then only it will do the filtration. That's why we may lose this data integrity in Hadoop. In the functionality wise, uh, it has some limitations in data manipulation. We have wide range of features for data manipulation. The query language, what it will do, it will use a HiveQL. I told you, right? This will use a HQL. Actually, we have many uh, types of query language we have. We have mainly this SQL. Try to learn the SQL. We have this HQL, TQL, transactional query language, NoQL. NoQL is for the uh, unstructured databases, or we have this PLSQL. PLSQL also we have. What is that programming SQL? Using this, we can do some of the programming. We have many. So out of this, uh, if you learn SQL, all the syntax, all the concepts, whatever you have, almost similar. Okay. Oh, let's discuss about the Hadoop architecture. Okay. So as each and every component have the architecture, just like for the Hive also we have this architecture. Let's see where I can find it. Yeah, this one. Yeah, this will work. Yeah, normally, okay, this is little complex. But normally, if you see, look into the Hive, actually, yeah, this is how the Hive works. Uh, we'll discuss it clearly over here. So, we'll discuss one by one. So, actually, I'll tell you how the Hive works line by line. Initially, if you say it will follow some of the steps, it has some components in internally in the Hive architecture, then only all it work together. Here, it will uh, this uh, will be the like a final out became the final output for the Hive. For example, every component work together, then only Hive will work. Else, it will not work. So how this works, I'll tell you. Initially, on top of everything, we'll have this SDFS. What SDFS do? You know, like it will store the large data sets across all the clusters and all in the different nodes. And uh, on top of it, we have this Hive Metastore. What is a Hive Metastore? What exactly Hive Metastore do? I'll tell you. This Hive Metastore is nothing but uh, it's kind of a where it is. Yeah, you can see it right. Hive Metastore. Saved it. Okay. So okay. Actually, if you see on top of it, uh, we have only mainly these components. This is actually a little tricky. Uh, we'll discuss here. Yeah. So we'll discuss first the Hive Metastore. What exactly Hive Metastore do? It will store uh, things like where or how and what. So it will store the what exactly happening, how exactly the data is flowing. Everything will be stored in this Hive Metastore. So this Metastore will store the metadata. What is the metadata? Metadata is nothing but information about the data. So what are the data you are coming in? For that particular one, you will be having these columns and all. What exactly these columns do? That comes under the metadata. I'll show you. Let's take, I'm holding the employee ID, what is 100, Stephen King, everything here. This is actually data. Metadata is nothing but this is the metadata. What it is saying, the metadata is nothing but uh, how what is the column name, what is the data type, whether it is nullable or not, and what exactly this column do. For example, see, the employee ID will store the primary key. Or example, say the department ID. What exactly the department ID do? Department ID will store the department ID where the employee works. Okay, like that, it will store the information about data about the data. So that's how it works. What exactly it will store? It will store the table schema, means the definition of the table. Okay, what are those? Like column names, data types, what exactly, data length, many, like order, um, the data, how the order should be. For example, business is asking for the this is order. If I place this job ID first, will it make, is it correct? No, right? So even we need this data order as well. So this is kind of a table blueprint we'll have in the metastore and data location. So in actually HDFS, it has different locations, right? So where exactly this kind of information is storing about maybe a file paths and the location. So it will, for example, if I go and if I'm saying uh, to Hive, go and check for some data. I know there is some data is stored in the HDFS. Maybe in the it's the data stored in the node 20 with information called book. So I'm not sure. So this information stored in this file path or the location, it will save that information whenever you are trying to retrieve that. You are trying to access that. That will tell you this path and location. That's how this will be useful. So it will store only the metadata information. The next thing comes under the Hive driver. Okay, we'll try to wrap it up soon. So Hive driver, what it will do, where it is Hive driver. This is Hive driver. Either it driver works on based on the uh, uh, Hive CLI command line interface where you will type all the commands, or else you can use the web UI. Web UI I will show you tomorrow. In the web UI, you will submit the queries. Whatever you want to do, you will write your queries over there, just like Hue editor. It's one of the tool actually. It's a tool. So just like Hue editor, I know only Hue editor. So that Hue editor we can access through browser, and we can run the queries over there. Whenever you are running queries, this driver will try to capture what the driver do. This driver will accept the query, and it will create an interface between this driver. It's kind of a, driver, what normally driver do. Let's take a car driver or bus driver. Just a second. So driver will take the passengers. uh, he will or she will, like they will take the passengers from one place to another. Just like, for example, this is the interface where I am working. From this interface, I am giving any query. It will interact with this interface. It will take the query. It will give it to the compiler, metastore, or execution engine. How it works, we will discuss. Okay. So what exactly this driver do? Whenever you're doing any query through command line interface or through any UI, or we have many third-party tools where you can connect to the Hive. and you can run your queries even from the Power BI or Tableau. Also you can access, you can run your queries. Next we have the Hive compiler. What Hive compiler do? Normally this will translates the HiveQL queries to Hadoop understandable language. So compiler, I told you. So compiler is nothing but from the higher level language uh, which can be understandable by the humans to the machine language. It will which is a machine language. So it will try to uh, convert that one. What exactly it will do? It will try to understand the schema from this metastore. It will generate one instructions. How it will works? Uh, it will understand the table schema. Later, what it will do? It will generate some instructions to what? To map reduce jobs. And next, what happen? And it will process this data to store in HDFS. Okay. So this is a backend. The entire thing will happen. So what is okay? Jan, later on we'll give you this information to Jan, and later this will go to this map reduce, and this will go to the Hive server. So before that, what exactly it will do? I'll tell you. So whenever you're running any query here, it will come to the driver. After the driver, it will go to this compiler. Compiler, what will do? Uh, so first of all, this driver try to interact with this interface and get the information, and it will give that information to compiler. Compiler, what it will do? This compiler will try to convert that information, and it will give it to the metastore and see whether that schema or table. For example, I want to store some information in the employee table. So if you want to store that table, right, you need to see whether that table exists or not, or schema, everything. Okay, there is one table with some schema. Fine. That information will give again given to a compiler, and this will be given to the driver, and this driver again will give that information to the execution engine. Okay, you can see the numbers, right? 1, 2, 3, 4, again 4, 5, 5 to 6, 6 to 7. Okay, so it will come back from here to here, uh, and it will give it to the execution engine. What exactly this execution engine do? This execution engine will this is one component and this is one component. From this environment to this environment, this execution engine will uh, keep on continuously what exactly it will do means it's keep on continuously uh, sending and receiving the data. Okay, that's how it works. kind of a data processing or parallel processing it will do between multiple nodes, so that then it will again, it will go to the this yeah, before going here, I gave you this meta store, right, to this compiler and driver. This execution engine will check that uh, schema. Again, it verifies here. If you see here, 7.1, it will verifies here, and again it give it back here. So there is two. If you see here, this engine, there is a two-step verification we are making. So that's how it works. Actually, I'm not sure why exactly it is, but it will do some kind of two-step verification, and it will give it to the execution engine. Then again, this will given to the job tracker where we will do the map reduce part. So uh, what exactly map reduce will do? It will assign any resource for the work allocation, and it will create this execution will create the nodes and all, and the data will be processed here, and it will be saved in the different nodes, the main node and the data node. So like this, the architecture is there. Like whenever you are making something, uh, it will, we have the interaction between the Hive and the Hadoop. Hadoop means like the internal system, how that it is working. So this Hive will actually, this Hive acts as a top layer for everything. Okay. Till here, you have any doubts or questions? Okay. So uh, coming to this Hive one, it has a scalability. Means if you want to, if something data is massive data is wouldn't handled by the one server, we can add on one more server, and we can scale it, and we can create multiple nodes on the clusters, and we can work on it. And coming to this high part, it is easy to use. Means, for example, if you know this SQL, right, it's similar to SQL only. You can simply learn the HQL. Okay. It's not something you need to learn some of the complex programming language. If you know SQL, that's a use easy. And even this uses this data warehousing concepts. Anyhow, we covered this data warehousing concepts, right? So it uses some of the data warehousing concepts, and it has advantage of schema on read. So schema on read is nothing but, unlike all the databases, so it will give the data, and then only it will read the schema. So the disadvantage here with this Hive is like, it can only do the batch processing, not a real-time processing. So the whatever the Hive we are working, it's not ideal for the real-time analysis and all. It can do any large number of data sets you do, or it can do it, but it can't perform the streaming job. Okay. So till here it's fine. So this is some of the introduction we have. So tomorrow we'll try to see how this, I told you, right? This where exactly we will work, mainly we work with this UI interface only. We'll submit our queries here. So uh, we'll discuss about the the basic data types or operators we use, or how we can create and delete the tables over there, or how we can load the data, or we'll discuss tomorrow. Okay. So I'll try to cover the HQL, which you can learn in reverse way also. So if you learn HQL also, uh, it will helpful for you to understand the SQL. So like I'll try to cover up some of the SQL concepts in HQL only. Okay. Any doubts or questions still here, like in the Hadoop ecosystem or the Hive one? Okay. Like so whatever previously we discussed, it's kind of a theoretical one. From tomorrow onwards, we'll start the practical sessions. I'll okay, I forgot. Just a second. You can go back and check for this Parquet and map edges. Okay. Today. And I already shared that Google Drive link, right? So you can go through that as well, and I'll try to upload these documents and recordings also. Can you all able to access that Google Drive?
Yes.
Okay, fine. Okay, fine guys. Like we'll connect tomorrow at the same time, and we'll continue.
Okay.
Yeah. Thank you all. Have a good day.